So today we are going to start this question, count distinct number on the board. Okay, so the question is saying that you are given a positive integer, right, and that is initially placed on a board, and every day for 10 to the power 9 days you perform the following procedure, right? So question saying for each number x present on a board, we have to find all the numbers I is greater than or equal to 1, and for all what I, it is greater than I is greater than 1 and less than or equal to n, such that if we'll do the modulo of I, that is equal to 1. Okay, so then we have to place those numbers on the board, and so if we want to return the numbers of the distinct integer present on the board after 10 days that has been elapsed, right? Means total number you have given n, and you have to place on the board, right? Initially it is placed on the board, and every day for 10 to the power 9 days you have to perform this procedure, like for each number x present on the board we have to find all the numbers that is between let's suppose I is greater than 1 and less than or equal to n, right? And if we do the modulus where x is modulo of I and equal to 1, right, then we have to place those number on the board, right? And then we have to return the distinct integers present on the board after 10 days that has been elapsed, right? What do we have to do? We have to take care of two nodes. One number is placed on the board, and it remains on it until the end. And then percentage, we have to find the modulo of operations, and for 10 to 10 14 modulo 3, that is 2, right? This is the example. Let's suppose we have given example n equal to 5, correct, and we have to find the output of 4, correct, output 4, right? So let's understand n is 5. So initially 5 is present on the board, correct? It is saying initially 5 is present on the board. So the next day 2 and 4 will be added, because 5 modulo 2 is nothing but, let's suppose 1 we are getting as a remainder, and 5 modulo 4 we are getting 1 as per the expectation, right, that we have here. Okay, so what will happen next day? 2 and 4 will be added, because if we do the modulus of this 5 with the 2 and modulo of this 4, we will get what? 1. So whatever that is come reminder as 1 1, then we will add into that value. So 2 and 4 we are going to add on to the board, right? Next day, after the day, after that day that we have added already, right? So after this day we are going to the next day, right? So 3 will be added on the board, because if we'll do the modulo of 4 with the 3, we will get what? Remainder will get 1, correct? So what will happen after that, because we have to add that one, if we will get the modulo, right? After that day, end of the billion day, right? What will happen? The distinct number on the board will be 2, 3, 4 and 5, right? So total element is what? 2, 3, 4 and 5 we are getting, correct? So what we will do, this number we will add onto the board, right? And we have added on the board, right? So total count we will do that. So we are getting 4 element, and that's why we are returning 4. If we'll talk about the another example, that what we have input n equal to 3, we are getting output 2. So since 3 is modulo of 2, right, and we are getting what? 1. So what we will do, we will add 2 on the board, right? So after the day that is done, right? So after the billion days, what will happen? The only 2 distinct numbers on the board, right? 2 and 3, because first we had 3, right, n equal to 3, then we have did -1, right? That is we are getting we have added 3 modulo 2, right? That is we have done already, right? So what we will do, 2 after one day we have added 2 now. So now we have 2 and 3 on the modulo, right, on the board, and that's why we are getting output as 2. Similarly, you can take any other value and implement. So what we will do here, first of all, we have what we have taken here. First of all, we will take the board, right, and on the board we will add all the number that has been placed, right? So initially we will place the number that we have given n, that will be placed on the board. Now days start from 0 to it's 10 to the power 9, right? That we have given like this one, 10 to the power what we have 9. So after the elapse of these days, right, till that we have to go from there, 0 to that day, 10 to the power 9 days, right? You see here. we have given here, 10 to the power 9 days we have given, right? So if with that implement, that is one left shift of 9 we have to do, and day will start from 0 to 9. Next we'll take one integer, what new numbers, right? And new numbers we have. So what we will do, for each number on the board, we will get from the board, right? And for that, what we will do, we'll find the we can say remainder, right? How we'll do that? For all number I, we have to find x modulo of I, that we will get equal to 1. So for that, what we will do, we will start with I equal to 1 to less than equal to n, and for all the 1 to n, we'll check the remainder. Those remainder is coming to 1, we will add on to the new numbers, right? This new number, and these new numbers have a set like that we are getting, right? 2 3 4 5 we are getting, right? That we will have on the new number as a has map, right? Has set, sorry, as a unique value. And then all those value we will add on to the uh, new numbers on the board, right? Why we are taking the has set? Because for each time, for all this row, right, we will get the duplicate value, right? And that we will add onto the number, so it will become very vast number. So only we have to remove the duplicates, and we'll store the unique values. And that's why all those value we will add on here, right, after adding on the sets. Once we have, then we will return the board.size, and it will work. So if we'll compile and run this, it will work for you, right? So thank you guys, thank you so much for watching this video. Please like, subscribe this video for more videos. Thank you so much.